The development of nanoparticles nowadays has increased in order to answer to humanity's needs. A nanoparticle can be defined as a particle that is smaller in all three dimensions than 100 nanometers. Nanotechnology is applied to several work fields such as medicine, pharmaceutics, textiles, and much more. Imagine having a blast with your friends like any normal day, but feeling under the weather for no apparent reason. How many pills do you need to take to feel any better? Or if you already have a medical condition like diabetes or cancer, how excruciating is it to feel good? Nanoparticles are the solution. They can be modified so they can serve as medicine carriers, as well as being programmed to release the amount of pharmaceuticals on a certain time basis. The drug can be located in different areas of the nanoparticle, in its semi-porous surface or in its nucleus, among other areas. It's necessary that the nanoparticles know its focal point in the human body once it's inside. The nanoparticle can move throughout the body by different stimuli that activate the immune cellular system. There are some cases in which the nanoparticle is covered with hormonal receptors or specialized antibodies. The reason nanoparticles are used as drug carriers is because of their ability to surpass biological barriers.
Any study that involves nanoparticles needs to define them morphologically so their physical and chemical properties are well known. Also, by defining them, their stability to the environment is known too. On the other hand, nanoparticles can be given any characteristics depending on the need. For instance, they can have imaging abilities and magnetic abilities as well. There are several ways a nanoparticle can be prepared, especially single-chain polymeric nanoparticles like emulsification, evaporation, or nanoprecipitation. Emulsification evaporation is based on the solution of a polymer in an organic solvent. Simultaneously, an emulsification is prepared by adding water and surfactant agent to dissolve the polymer. After the homogenization process, the solvent is evaporated and finally the nanoparticle is created. Single-chain polymeric nanoparticles are obtained by centrifugation.
Some other applications that involve nanoparticles are enzymatic immobilization as antibacterial agents in the electric field and other biological applications. As antibacterial agents, they are able to deactivate some fungi and some bacteria that are threatened to human life and other animals.